Yeah.
Okay. I revealed your first lab in this class last week. I forgot to look at when I made that due. Did I make that Friday? I like to make things due on Wednesday where I can, but I also didn't feel like it was fair to, especially for the first assignment. I recall last quarter, there were a few roadblocks for this. So I want to give people a little bit of time to iterate on it. Just because it's due Friday doesn't mean you should start it Thursday. Please start earlier than that, this Friday. Start early. There will be quite a few issues that you'll run into, questions that you'll want to get answered by the time things are due. So please start today if possible. And in the meantime, we are going to be talking about our next design pattern. My goal is to give you a lab on this design pattern this week that will be due next week. And then we have one more of these to go before I assign our big quarter-long project that will be due toward the end of the quarter, but I want to give people a long time to work on it because there's going to be a big design portion of it. I'm not specifying exactly what your project needs to look like. I'm just giving you some basic guidelines around the edges, and the rest of it is going to be up to you to figure out how do you want to structure your project. So because of that, I want to make sure that there's enough time for that whole design process. So you'll be designing UMLs, you'll be bouncing those ideas off of each other, off of me, as you figure out exactly how to do this. But it will involve the first 3 design patterns that we go over. So strategy, we already went over that. That will be part of the project. Decorator, what we're starting today, is going to be part of the project. And the next one we talk about, builder, will also be part of the project.
When we get our tests back?
They have not yet been started. The goal is to get them back to you by Friday. I like to have 1 week turnaround where possible.
Okay.
But the TA for this course has never graded this course before, and I know exactly how that process goes. So there's probably going to be some questions that they have for me. So there's going to be some communication and going back and forth. So as much as I would like to get them to you sooner than that, I would rather have them graded well.
Just want to know when you should expect them.
Yeah. Would rather have them graded well than graded fast.
Okay.
So today we're going to start talking about decorator. Does anyone have any other questions about class, about anything else before we get started on new content? All right, let's do it. So we're going to start talking about decorator. The motivation for this is that your company, maybe you're the only member of your company at the moment, you're a nice brand new startup, you're going to design an ordering system for a brand new coffee shop that has just opened up down the street, since we all know this area needs more coffee. Like I think this area needs more coffee. So you are told that you need to design this associated functionality. We should have a description of the beverage. So when you're in the ordering system and you want to order, for instance, a latte or a mocha, there should be a description of the drink that you are ordering. So a description, you also need a way to access that description. Beverages have costs, so we should be describing, find a way to display the cost of the beverage. For each of the drinks that you can order are a house blend, a dark roast, a decaf, and an espresso. So go ahead and design a solution. We've now talked about UML class diagrams, so think about drawing out the associated class objects in a class diagram, and then draw the associated relationship arrows between those classes that you think will allow you to get all of this functionality. Go ahead and do this you can do it in small groups if you'd like. I would say even up to 4 people.
I feel like this.
Yeah. So that is.
So,
Like and then you would have to reach from the class. That's good.
I don't think it's good. Yeah, they need a new description.
Yeah. Those are all going to be in the oh, and then it'll be a class. It'll be like a subscription.
So you just need description and then it's not right.
Yeah.
So then you point this off. And then you use cost. What we should do is we should use description of the point these problems that each as well. And to do that. Right now. So this, these here. And they'll each have their own. And now. So description. All. Yeah.
So that's right here.
Oh, like.
Oh, I see, that's what, that makes sense, if you can do that, then.
So that you get to, yeah. Like, sort of one. Just from. I mean, instead of having this, you have that, it's making it in your house. Yeah.
They all include this in the
Arrows. Well, yeah, just do that.
I think that,
Yeah.
Yeah. So.
How are people doing? I hear some good discussions happening. Maybe we can discuss some of what you have come up with so far. So anyone willing to share their idea or talk about any pros and cons of their proposed solution to this? Anybody want to share their solution? Yeah.
So we decided to do like a generalization, drawing diagram. So we started, so our thing on top is our beverage class or method, and then underneath that, we have an arrow pointing to that beverage class that has our beverage cost and beverage description. And then from there, we have a line connecting to a box that has get house blend, get dark roast, get decaf, get espresso. And then that's what we got right now.
Okay. Sounds reasonable. Anyone else come up with a different design? So the basic functionality that I expected people to come up with looked something like this, where we have a beverage abstract class where there's a description that needs to be done and a cost that needs to be inherited by all of these subclasses, and each of the subclasses would be a different drink. And each drink would have a cost that is associated with it. So you could make an object, something like beverage B equals new house blend. And we would call the house blend constructor. And then when we access, we would say something like B dot cost, it would call the cost method associated with the house blend object, because that is the concrete object type that it is. So this is a standard inheritance hierarchy where we're implementing the cost because that is what varies. So there's a description of each beverage, and then we would need to be able to get a description somehow returning the description that might also be implemented in each of the subclasses. It would depend. What do we think? Pros and cons of this?
Couldn't you easily expand it? You need to add more, just add your subclass, whatever type of drink you please. Go on and on and on and on. It's
We
super
could.
easy to do.
We could, if we decided to have a new drink type, we could just add that as a new class. Who here is at least a reasonable coffee aficionado, meaning you walk into a coffee shop at least, I don't know, once a year? A few people, most of you
I
maybe?
have coffee at home.
What would this not support that an actual coffee shop does support? Yeah, toppings, things that you could add. Is there the ability to do things like add an extra shot, or you can customize your drink in some capacity, like substitute some ingredients from other ingredients? Maybe you want to substitute whole milk for soy milk. Maybe you want to So we can't really easily substitute, we can't easily add toppings. So there's some functionality that we might be able to want to add to this. How would you incorporate that?
You could probably add the description customization as another function in beverage, and then a customized option for each subclass, like the customer class will work for every single beverage with no exception. So the customization automatically apply to your beverage of choice, right?
Interesting.
Then customize can be also blank, we don't want to customize.
So you'd have some kind of customize that we'd have some options for how to do that for each drink. Let's take a deeper look at the extendability of this. So your client comes to you and says that they now want the ability for a drink order to add condiments, steamed milk, soy milk. We can add chocolate to a drink. We can add whipped cream to a drink. What would the functionality look like? We have one idea of kind of a customized method, but what would that look like? So let's take a little bit, take your UML diagram and try to include that functionality in there somehow. So get back in your groups and talk about now, how could you possibly adding condiments?
Basically.
Oh, actually, yeah, you can do that. So that way, if you think of consumer money.
I think that basically, main beverage.
So this one has
Then
description,
compliment,
and-
like a milk glass. But
but this one requires. I mean, it should actually.
And that.
If it wants to.
So it's just like a great.
So that would.
Come up with any ideas? What do we think? Is there an easy way to do this? Anyone want to share their ideas?
We made a modifications class that extended beverage, and then you could add like, add shot, add toppings, whatever else you can do to coffee.
Okay. How would that do things like affect the cost of the beverage? Are you assuming that
Yeah.
a user can order a 10,000 shot house blend?
Yeah, you can.
Did you not?
Who is being big also shots of coffee?
One of my past coworkers.
Like, you guys, volume of liquid.
I thought that about him too. He was a little insane.
Are you serious?
Yeah, he would, oh, I don't know about 10,000, but he would drink, he would come with a bottle of espresso and probably have the equivalent of about 12 cups of coffee in his system within an hour of starting teaching at 8. And then just continue that process throughout the day,
What?
which is wild.
I guess he has ridiculous caffeine tolerance or something.
You have to build that up, but
That's a lot of coffee.
it's a lot.
So about 3 or so cups a day. That's like average adult.
Yeah,
That's
So I was thinking we could make like a second abstract class called toppings. And then we
okay,
could have a list of those inside the beverage class. So that like when you add the topping, it changes like the cost and everything. And
okay, so when you calculate the cost, you would query the object that says, what are the list of toppings that we have for this particular beverage? I like that.
Yeah.
That's a reasonable solution. Does it work for any possible order? Are we able to construct that on the fly during runtime? The answer may be yes. But that's something that's going to be kind of important, right? Imagine that you're at a drink kiosk and you're actually using this software to be, tapping, I would like to add, I want this drink, I want to add these toppings to my drink. This should be updating on the fly as you go, so that you see the cost update, the cost update, the cost update, something like that. So that's a perfectly reasonable solution, because if you're using something like an array list can resize at runtime. An array list can change, and you'd be able to query all of that at runtime. What did I do? All right, so let's take a look at one possible solution that's probably not as good as the solution just suggested.
What? What is that monstrosity?
Here we have as
This is just horrible.
extending from beverage, we have espresso with steamed milk and mocha, espresso with steamed milk and caramel, espresso with whip and mocha, decaf with soy and mocha, espresso with steamed milk and whip, espresso with whip and soy. We have every possible combination of drinks and toppings, but we would be able to identify the associated cost for each one of those objects. What do we think?
No. Just no.
What are the real cons? If we had to outline the cons of this and actually put those into words, what would the cons be?
Disorganized.
Definitely disorganized. How extendable is it? Let's say I wanted to add a new drink. How many classes am I adding if I want to add a single new drink?
Way too many.
Every possible combination of toppings? What if I wanted to add a new topping? What do I have to go think about?
Every single pot drink.
Not just every drink, but every single drink combination, because you need to add that topping to every possible combination of toppings with that drink. This is a logistical nightmare.
Hence my no commentary.
So inheritance by itself is a terrible idea. In terriblance, we can make that work somehow. So let's actually talk about a real possible solution. So we didn't even talk about what happens when the price of milk goes up. We've had some pretty bad inflation over the last couple of years. So you can imagine as a business, this cost method that you would have to call when milk goes up, you have to go edit the associated cost of every drink that uses milk.
Oh, no.
So, problem. Many problems with this. So let's throw that out the window and attempt to redesign. We'll start by collapsing the inheritance hierarchy. So we will now try to use composition rather than inheritance. Remember that we said favor composition over inheritance as one of our object-oriented principles. We can now start to see this again, because if you try to make an inheritance hierarchy for everything, you frequently see exactly what you saw on the last slide, where you see an explosion of the number of subclasses. And as you add more and more to this hierarchy, you start to add a geometric number of subclasses, which is not good. So let's start out by thinking about each condiment is a Boolean. So you can imagine that a drink has milk, has chocolate, has a bunch of has whatevers. And then we would be able to see whether each drink has each condiment. We would then, since each of them is a field, we would want getters and setters for each of them. So you can imagine being at the kiosk, tapping that you want to add chocolate to your house blend to turn it into a mocha. And then when you do that, you would be calling the setter for the has chocolate and turn that to true. Maybe as part of that, you would have some kind of update cost that takes in one of these objects. And then you could then update the cost for the fact that has chocolate is true. Then if you tapped it again, it would undo that, change that Boolean from true to false, call an update cost method of some kind that would then revert that change. So we would have a cost function calculating the total cost based on all of the values of all of those fields in the beverage class. So you would just go through and loop for each of those, calculate if it's true, add the associated cost. If it's true, add the associated cost. We would continue to have our old inheritance hierarchy for beverages, but now instead of needing each combination of condiments, we would just have a single base beverage and type of beverage subclass, just like we had in our first image. So here's what that redesign might look like. First of all, querying the class. Reasonable solution? Yes? No? Does it seem better? It's definitely better. The question is it fully reasonable?
Yeah.
Are there cons associated with this logic? What could we identify that might go wrong? Think about that as we continue to talk about it. So here's the system. We have a beverage class with fields now for the description. Has milk, has soy, has mocha, has whip. And then we write the associated getters and setters, so we can return true or false, whether or not the drink has milk. We can set milk to true or false. Has soy, we can set soy to true or false, etc. And then there's an associated cost method for each of the drinks that can then query the beverage superclass to figure out, does this dark roast object have milk? Does this dark roast object have soy? It can calculate the associated cost based on that. What could go wrong? What issues might exist with this design? This is not perfect. Yeah.
You could maybe like forget to set one of them, like I'm gonna, or forget to like write one of the methods, like set method, get method.
It would be inherited basically from that superclass. So none of these subclasses, I think, could have that as an issue as long as we had it in the base class. It's a good idea. Other cons, what else can we think of? Yeah,
I was thinking, what if the cost changes for some of those ingredients?
yeah, we'd have to go update the cost function in every single subclass. Yeah, there aren't quite as many, but if again, the price of milk goes up, then a house blend, we'd have to go modify that cost method in the house blend to change how much adding milk to your house blend costs. And then you'd also have to do that in the dark roast cost method, and then you'd also have to do that in your decaf cost method. So there's still that issue. It's not as prominent as it was under the ridiculous idea, but it's still something you'd have to go manually change, which is not ideal. So we just identified this. Price changes forced us to modify existing code in multiple places. That's not ideal. What happens if we want to add a new condiment? What do we have to modify in order to add a new condiment?
Could you probably add more percent functions per comment?
So we'd have to add a new field in the beverage superclass?
Yeah.
Yep, we'd have to add new getters and setters. We'd
Yep.
have to update the cost in each subclass for the new condiment.
So not as bad as the previous one.
It's definitely not as bad as the previous one. I started with that for a reason. It can't get worse than that.
Nope, incarnate. This is like manageable comparison.
So all of this is going to be modified in some capacity. So what about beverages that don't want every option? Like for instance, does it make sense if we wanted to add an iced tea? Does anyone want to order their iced tea with chocolate and whipped cream?
No.
So maybe we want the ability for different drinks to have different topping options. We don't want every drink to have every topping option, because someone's gonna walk into the shop and be like, iced tea with chocolate and whipped cream? That sounds weird. I'm gonna try that. And then when they write the Google review for later, that this store sells disgusting drinks, never go there. So maybe it makes sense to only allow them to add appropriate toppings on a per drink basis. So taking all of this together, let's talk about one principle of object-oriented design. So we want classes to be open to be extended, which means that we can add new classes that add additional options. So things like if we wanted to add a drink, we should be able to add a class into the existing hierarchy. But they should be closed for modification. Nothing that we extend should force us to go back to existing code and modify it or edit it. That introduces lots of bugs, and we don't want to change a complicated system that's already working. So we don't want to modify existing code whenever we want to add new objects. So the designs that we've talked about so far, of course, can be changed through extension. What that means is as new requirements come in from a client, it's unlikely that a new bug is going to come up. If it does, it was because of the change that you made to the older completed code. If you actually apply the open close principle, any bug that you introduce is going to be based on the new code. It can't possibly be an issue with the old code, because the old code was a system that worked and you did not change it by introducing the new functionality. So the open close principle is very important to attempt to adhere to. As with most object-oriented principles, it's a principle. It's not a rule, a hard, fast rule. There will be times where you do not want to do this because adhering to it is going to create way more work than it solves. But it's a general principle of, in general, it will create less of a headache for you if you adhere to this. There's usually a beware associated with any principal, so should not be applied everywhere. If you have reason to believe that the code that you write is never going to be extended for any reason, the requirements of this just will not change, then it's not worth going through the time to make it adhere to the open close principle. It's very similar to writing more and more and more tests. At some point, you've pretty exhaustively written tests for things, so there's no need to do more work for no more gain. So adhering to the open close principle takes time, effort, energy, work hours, man hours. It can also make your code more complex and difficult to understand. So it's a real trade-off. We do this in order to make it extendable such that when extendability comes in and someone says you need to be able to add to this, then it is as easy as possible and produces the fewest bugs. So all of this leads us to the concept of the decorator pattern. So the decorator pattern is going to be what allows us to make this coffee shop really work and work well. So the idea of the decorator pattern is you have a base instantiated object. So the example that we use here from the coffee shop is a dark roast object. We can decorate it with a condiment. So we will decorate the dark roast with a chocolate object, turns it into a dark roast mocha. We can decorate the dark roast object that's already decorated with a chocolate object with a whipped cream object. And now what we have is a drink wrapped with 2 additional condiments or toppings. When we call the cost method now, we call it on the outermost decorated object, and it knows how much that particular topping costs, and then it will recursively call the cost method on the object that's inside of it, which recursively calls it on the object that's inside of it until you get down to that base dark roast object. And then as you go back up the recursive chain, it will be summing all of the costs of the associated toppings and the base dark roast object to give you the total cost of the object. And that way, it can have an arbitrary number of toppings, and the cost is made up of itself its own objects. So for instance, the chocolate object may cost 50 cents. It's very easy now to go modify the chocolate object when inflation hits to make that cost 75 cents, and it will apply to every drink that ever gets decorated with it. You don't have to go modify it for each separate object, because instead of it being a field inside of a class, it's its own object. This idea is exactly the same as wrapping the primitive int with the integer class, or the primitive double with the double class. So these wrapper classes that we've talked about add additional functionality to the base primitive type. So for instance, how does one in Java convert an int to a string? Yeah, the toString method. Does an int have a toString object or toString method? No, the integer class has a toString method. So what we have is we have this concept of this box that can hold an integer. Maybe it holds 5. This is what an int is. That's all it is. It has no other functionality than just the value of the integer. But if we wrap this value in a class that we're going to call integer, we can add additional functionality. Here's a field that is the value of the integer. This is an int field. Well, we can define a toString method inside of this class that converts this integer into a string. So here is an example of adding functionality by turning something that is primitive into a class. So if the chocolate object, all it is how much we add to the cost of something, we can do exactly the same thing by taking this cost of a chocolate object, turning it into a field within its own object, and then we can define methods of something like, what is the object that is inside of this object? And then the cost for this, we'll just call the cost for that. So it's very similar to this concept of wrapping a primitive variable in additional functionality. Does anyone know anything else that's inside of the integer class? Have you used anything else that deals with capital integer, capital I integer? Does anyone know offhand what the largest value an integer can store is? Does anyone know how in code to access the largest value that an integer can store?
It's like a big number.
It's a big number,
It's something, it's something.
but it's a field in this class. Yeah, there's a public static final int that we're gonna call max value. Equals whatever it ends up happening to be, 2 point something billion. If you ever need access to this, just call integer dot max value, and you will grab this value directly out of the integer class. So it adds a ton of quality of life to the primitive object. Just like max value exists, min value exists, there are plenty of other things that now anything you'd ever want to do to an integer or be able to look up about an integer is now stored within this wrapped class. Questions on this logic or how it's done? We just have a field that represents its value. It's like an int value. That is the value of this integer. So we are going to do exactly this same thing to beverages. So here is the dark roast object that has its own cost. Here is a dark roast object decorated by a mocha that also has a cost. And now if you wanted to figure out the cost of your dark roast, you would call this object that has been wrapped dot cost. The cost would access the mocha object. The mocha object would add the cost and recursively call the cost of this dark roast object, which would then return the actual cost. This is an actual value. This cost method would be defined to be something like 0.5, 0.0, or yeah, 0.5 being 50 cents, plus the cost of whatever it's wrapping. So we would then access this, which would then be able to return the total cost of the object. This can extend arbitrarily large. So now we have a dark roast wrapped with a mocha wrapped with a whip. It says a dark roast with chocolate and whipped cream has an arbitrarily long cost chain to calculate the total cost of this drink. So this drink now would be a whip. Inside of that whip is a mocha, inside of that mocha is a dark roast. And we can calculate the total cost that way. Let's talk about exactly how to do it. So 3 different cost methods. How are we going to calculate all of them? And the answer is just recursively. So we call the cost on the outermost object. That cost calls the cost of the next object, which calls the cost of the next object. And this book is super old. I don't know the last time you could get a dark roast for 99 cents or add anything for less than $1 or 50 cents. But yeah. It returns the cost of the dark roast object, it adds it to this cost and returns the cost of a mocha plus that. So this is just summing as we go back up the recursive chain until we end up with the way outdated cost of a drink. Does that intuitively make sense? Is that concept of how to calculate the total cost if you have objects embedded within other objects as fields? So as we construct this object, we would basically be saying, we're gonna have this dark roast object. And then it's going to become a field of this mocha object. This is now just a field of this object. This entire object is just a field of that object. And then this is a field of this object. But now when we want to execute the cost of this, we have to, in order to answer the cost of this object, we need to query the cost of this object, which we'll call this cost method. So we'll query this object and say, what is its cost method? And then we just go back the recursive chain and end up with an answer for how much this object costs. So here's how I like to think of this image as well, is in terms of the actual class objects from a class diagram. It's just that now we have a method that's part of an object that is a field of another object. That has a cost method, that is, this entire object is a field of another object. So we're finally using the full power of object-oriented programming. So we're actually going to look at how to code this, because writing the code for this, I think, is going to be a little tricky, even with the understanding of exactly what's going on. Before we should do so, we should actually define the decorator pattern. So a decorator is going to assign additional responsibility to an object dynamically. This allows us at runtime to decorate objects with other objects. When we make a dark roast object, we don't yet have to specify whether it is decorated with anything. At runtime, we're going to decorate it with a mocha object, or we're going to decorate it with a whip object. So this allows you an alternative to an inheritance hierarchy as a way to extend the functionality of an object. In practice, we end up with a diagram that looks something like this. So we have a beverage class, just like before. We have an inheritance hierarchy with that. The subclasses of the beverage are the house blend, the dark roast, the espresso, and the decaf. A condiment decorator is going to be a component of the beverage. So it's composed as well as inherited from. Very strange. We can get the description of a condiment decorator that gives us the description of a particular milk, mocha, soy, or whip. We can now decorate any of the beverage subclasses with any of the condiment decorator subclasses by allowing us to do this. So this is the image of the UML of how this is going to work. What we haven't really thought about is how to implement the cost method. We know it's going to be recursive, but what's it going to look like in practice? How should we implement get description? That also is part of a hierarchy. So we're going to come back to this tomorrow and get a full answer for how we are going to implement this and the complete final solution to our coffee shop. In the meantime, get started with your lab, your strategy lab. And come see me if you have any questions. Yeah. So what's there is an API. It's basically telling you, here are the methods and technical details that you need. A lot of the files there are HTML files. If you open them in a browser, you'll get the full API. Did you get as far as look at look at that? So basically, what you need to do is just implement that functionality that is defined.
And then we test.
Yeah, and then you're gonna write some additional tests beyond the tests that are there. Let me show you real quick. Goodbye, world.